Hola, mis amigos. I'm Dora.
And I'm Boots. And together, we make the greatest team in the jungle.
Boots! Come on, Dora! All right! Dora! Let's go! Dora, 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 the explorer! Dora! Boots and super cool exploradora! Need your help! Grab your backpack! Let's go! Jump in! Vámonos! You can lead the way! Hey! Hey! To Dora! Dora the explorer!
That's me. Oh my god, I've been studying for more than 2 hours and I still don't know what to do. I'm gonna fail my math test tomorrow and I'll never be able to have fun again. If only someone could help me. Where am I?
Hola, Dora. You're in the wonderful world of geometry.
Perfecto. I have a math test tomorrow and I need lots of help. Can you help me?
Sure, Dora. Just come with me. Let's run. That's okay, Dora. I'll teach you. Just be patient and listen. Vámonos al learning lab. The most difficult part of this math lesson is an indirect proof. This is hard because some people find it confusing because it's the opposite of a normal proof and it requires different thinking and steps. An indirect proof is very different than coordinate proofs and t-chart proofs. Instead of trying to prove that the proof is correct, you're trying to prove that the opposite of the proof is incorrect.
Can you show me an example?
I'm going to show you an example, but first I need my trusty textbook. Let's get right into the math. For direct proof, the first thing we do is identify the conclusion or the proof of the proof. Second, we want to assume the opposite of the proof. Third, we want to follow a line of reasoning until we reach a contradiction in some known fact, a given, a definition, or a postulate. And then last, we want to write our closing sentence. So we always use the same script. This leads to a contradiction in blank, therefore, and then we state the original proof. Let's get into this example. Here are all the steps of this indirect proof. So we start off by assuming that the measure of angle 4 is less than or equal to the measure of angle 2. And then we proceed on saying that the measure of angle 4 is equal to the measure of angle 2, which is pretty much the same thing we said up front. Then, we can use the exterior angle theorem to say that the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Then we use substitution to say that the measure of angle 4 is equal to the measure of angle 4 plus the measure of angle 2. And we can already see some problems arising here, Dora. And then from here on, it's just 0 equals the measure of angle 2, which is impossible because angles have to be greater than 0. Alright, so to end the indirect proof, we end with a little statement. And we're going to write, this contradicts the fact that the measure of an angle is greater than 0, so the measure of angle 4 cannot equal the measure of angle 2. And that's all, Dora.
Perfecto.
Let's move on to the next concept. The hinge theorem is the most important in Chapter 5 because they're used often and are very useful in proofs. Alright, Dora, this is the hinge theorem and the converse of the hinge theorem. The hinge theorem states that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second triangle, then the third side of the first triangle is longer than the third side of the second triangle. This might sound like a lot, so let me break it down for you in an example. So in this example problem, we have two triangles. One of them is triangle ABC and the other triangle is FGH. Triangle ABC has side AB, which is congruent to FG, and side AC, which is congruent to FH. We also have angles A and F. Angle A is 43 degrees and angle F is 30 degrees. That means that angle A is larger than angle F. You probably already knew that, Dora. But what we can determine from this triangle is that side BC is larger than side GH because the angle opposite that side is larger than the angle opposite that side. That's pretty much the hinge theorem.
Gracias. Thanks for helping me.
Alright, Dora, here are some tricky definitions in Chapter 5 that you might not know too well. A perpendicular bisector is a line that passes through the midpoint perpendicularly of another line. So see, here you can see that this line is going through the midpoint because the two sides are equal, and there's a right angle, so you know it's perpendicular. All of these perpendicular bisectors meet at the circumcenter, and the circumcenter is equidistant from each vertex, so it's the same distance from each vertex. Pretty straightforward. Alright, so an angle bisector is pretty much a line that splits an angle in half. These angle bisectors meet at the incenter, and the incenter is equidistant from each side of the triangle, unlike perpendicular bisector, which is equidistant from each vertex. Let's move on, Dora. The median passes from one vertex to the opposite side's midpoint. So it's a little confusing at this point, but it takes a lot of memorization to remember all of these different ones. And those two intersect at the centroid. Now, the centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So it's a longer distance from the midpoint, 2/3, to whereas it's only 1/3 to the opposite side. Finally, we have altitudes. Now, an altitude is a line that passes from one vertex and intersects perpendicularly with the opposite side. So it's like a perpendicular bisector and an angle bisector met. The orthocenter is where all the altitudes intersect. And fun fact, the orthocenter and altitudes actually don't have anything special about them, unlike the median, angle bisector, and perpendicular bisector. And that's all the definitions for right now, Dora. Now, Dora, I think that this is just really important for you to learn because all these definitions can really get clouded up in your mind. They all sort of sound like the same thing, and I think you'll do really well on your test if you study these definitions. Alright, that was a really fun lesson, Dora, and I hope to see you in the learning lab next time. I'm out!